Okay, so this is a new DLA tutorial that we continue from last week. We are going to develop a script from scratch. Okay, so here we are going to create a new script. So I have a note next to me. We have to create a C# script. We are going to call this DLA create. Okay. And we are going to create a empty game object, reset, and name it DLA. Yeah. And connect this DLA to here. All right. I'm going to double click to start edit. So what we need to do is in the first scene, we should actually have at least one seed being in somewhere, so we can have other builders to create around it. So we always need a seed and a builder agent. Okay. So what we are going to do is we are going to create a central seed, but we need a prefab for this. So we are going to bring a public game object, input prefab. And in the start, we are going to initiate. We are going to instantiate that one time, okay? So game object, new prefab is instantiate the input prefab. Oops, Control C, Control V, and on 0, 0, 0 position. So for that, we can just say 0. So it's an easier way to make a 0, 0, 0 position. And do you remember we need a rotation that is called a parameter called quaternia. For a no rotation quaternia, we call it quaternia. You can make it like the quaternia dot identity. So this is just default, a 0 position and 0 rotation. Okay. So if I save this now, and in my DLA, I'm about to insert a input prefab. Here, I can create a prefab. So in order to be able to make changes, I'm going to make a parent prefab called empty geometry called, let's say, DLA seed. Okay, the DLA seed will look like rectangular. So I'm going to just make a cube. And I think I'm going to make it smaller, around 0.2. 0.2, 0.2. That's 20 centimeter.
Soomeen, I'm a little bit lost. So you created, like, I don't understand the relationship between the seed and the cube and yeah.
Yeah, I just created this as a geometry. I'm going to put it under this.
So, but the DLA seed, it's a behavior or it's an agent? It's an agent, right?
No. This is a prefab. It's a geometry parent.
Geometry parent.
So, yeah, do you remember I was making a weird bubbly geometry last week? like, let me, up. Oh, did I delete them? But yeah, I was explaining how to just group geometries together. Yeah, that's it.
Okay, okay.
Yeah, it's just about grouping it, our geometry. So I'm going to just make this into a prefab.
Yes. Okay, I remember. Yes.
Yeah.
Yes.
Okay, great. So now when I go in there, the parent scale is 0, 0, 0 and 1, 1, 1. And you can just change the scale of this guy accordingly. I think for now, let me just match this as 1, 1, 1 together with the parent. Sorry, yeah, I could have just made a cube. Yeah, it's no difference at the moment.
Oh,
But
okay.
yeah, what
So
it
the prefabs are easier to make like a bunch of them, right?
yeah. But also to be able to make some local changes. Okay, but good question. Let me delete this. I'm not gonna do this. Yeah, so actually there's no need to make it into a parent at this point, yeah? So I'm going to just make a cube, scale in 0, 0, 0, and going to change its name to DLA seed. So this will become the seed, so I can like accumulate it. Yeah. Does it make sense?
Yeah, it makes sense.
Okay. So I'm going to make this into prefab. Thank you for the question. Really good. Yeah. And lighting. In the lighting, I generate lighting one time just to make everything look better. And I don't have to come back here anymore. Okay. And now you can delete this thing from the scene because we don't need it. We want to generate this from the script, right? So I'm going to play this. Oh, I didn't connect the input prefab, right? So if I connect this there, DLA seed like this, play, I created one geometry, right? Because that's what I'm doing in the start. Is that correct?
Yes.
Awesome. I'm assuming that you guys already have some JavaScript knowledge, so you will understand. So I might skip fast some of the basic terms like concepts like list or for loop, if statement. I'm sure you have knowledge on that from Casey. Yeah.
Yeah. Yes.
Okay, cool. So I'm gonna like skip those like basic terms. Yeah. But if you have any questions, just stop me and always interrupt me. Okay.
Great. Thank you.
Awesome. Cool. So what I'm going to do on update, I'm going to make another geometry. This is going to be a builder. So I have seed. Do you remember in the video, first part of the video? Here, do you see like these ones? Let me think it like this. So they are, we can call it builder, or we can think about it as a plankton. So it's a plankton that coral will eat, and they will grow. Yeah, when they eat, they grow, eat and grow. Okay, so let's think about it like this. Okay, so in the second one, I'm going to make another geometry. Maybe this time I'm gonna make it into spherical geometry and preset set to 0, 0, 0. I want to make it red so we can distinguish. And this one can be scaled a little bit smaller, just so we can see better. So maybe 0.3, 0.3, 0.3. All right, and this will become my another prefab as well. So this one I'm gonna call it DLA builder. Okay, so I'm gonna have the builder. Maybe we can think like this then. It's a bird and it's flying around randomly. And whenever the seed is closer to this thing, they will get some food and they grow. Yeah, so this is like the builder, like put the food and nutrition to this thing, so it's gonna grow. Okay. All right, so let's bring that in. Public game object. We can just say DLA, what should I call it? Input
Bird.
Input bird. Okay, builder prefab. Okay. And input bar could have been okay. Game object let me think, because I'm doing it slightly different from my note. Okay, so DLA, maybe we can make the builder. I think we need a builder here as well. Okay. Agent builder, then builder agent. Okay. And then I'm going to instantiate the input builder prefab and not in 0, 0. There's no rotation required. I'm going to start from a random position. So the random, we can create a random position. Vector 3 is new builder location. Builder location is a new vector 3D. And I'm going to create a random with range. So random range can create a random value from in a range. I can set from 0F to maybe for now 20F. Let's see. But you might want to change this value later. So I'm going to make this value a input value. So public float a world, let's say world size is, now I'm going to set it 20 and it's 20. Is that cool? Control C, Control V, Control V for all 3 axes. All right. Cool. Okay. So I created a bird builder agent and a new builder location. Oh, I need to use this one here instead. Okay. So what's gonna happen now if I save this now? Save, and I connect my builder agent here. I will see a new builder agent instantiate there. Yeah, do you see that? If I run this again, every time it's gonna happen in weird and different position. Now the problem is that it only creates on this range because it only creates from 0 to 30. So I need to create from -30 to 30. Okay. So we can grow in multiple directions. So this is a good way of also defining some of the directionalities. So from -30 to 30.
I have a question.
Yeah.
The builder location, is there a difference if you put it there or if you put it public? Because
this one?
No, the other one, the vector.
Oh, this one?
Yeah.
You can put it outside, but you only need to use it in start. So that's why, yeah, it's better if this is private. It's safer because you might end up needing this name to define something else in other functions.
Okay.
Yeah, but this is only used inside here. Yeah, so it's better to clarify what's local variables and what's global variables. So global variables are something that you have to use on that is required to be accessed by other methods, at least one or more, two or more. Okay, builder agent. So what has to happen is the builder agent has to update its position every time in update. Okay, so what we have to do is we only will have one builder agent. Of course, you can have multiple, but we are in this example, we're going to have one. And this has to be a global variable in order to be accessed both by start and update. So in order to do that, I'm going to Control C and Control V this here to declare that outside and assign value inside the start. So this is assigning value, so I can assign this value again and again. And in the update, what I'm going to do is I'm still going to create, I'm gonna copy this in update. So I'm going to create a new builder location. It's a random location in the range of -20 to 20. And I'm going to set my builder agent transform position as the new builder agent location. Okay, so now what's going to happen is there will be one agent generated in the start and their position will get randomized on every single frame. So it's very fast, but you can see that it's generated around, I hope it's correctly from -20 to 20. It seems like so. Okay. So what we are going to do now is we are going to let the agent and the agent to find the closest seed. And just add another seed next to it. So in order to do that, every time in the update, I need to detect and sort out what is, I need to compare with all of the agents, all of the seed. For example, in the second round, there will be 2 seed, right? There will be 3 seed, 4 seed. Yeah, so I need to have a list. I'm sure you learned how to use array list in processing, right? So we have to create something similar. So we have to create a list of all the seed inside. So we are going to make this is a private. I don't have to create it there. I'm gonna just, okay. I'm going to create a list of game object and all seeds. And in the beginning, it's a null. Null meaning there's nothing. But you can also, you don't have to do that, yeah, because we are going to define that very soon here. So here, before we create a game object, we are going to make it into a new game object. So that's how you create a empty game object list. So that's, hi.
Yeah, okay, so on line 11, as opposed to line 8 is just one single object, but line 11 is creating a list. Is that?
Sorry, can you repeat?
So we're making a game object in line 8, right? Public game object. That's one object. But with 11, you're making a series of objects in a list. Is that what?
Yeah.
Okay.
I'm defining a list, but
Okay.
this is still empty here.
Got it.
Yeah. And now after I create a new object, I instantiated this. And very soon I'm going to add this object. So add new prefab. So now in this all seeds list, I have one object after the start. Okay. Cool. And I'm going to add a new agent every time I do this. So Control C, not Control C yet. Yeah. So I'm going to, what eventually I have to do is with my builder agent, I have to, from the builder agent's point of view, I have to test my distance with all of the seed. Yeah, and I'm going to just get the closest one, and I'm going to give a food to that seed. So what I'm going to do is I'm going to use for int I is 0. You now know how to use for loop. I is smaller than the seed's length, I plus plus. This means I'm looping through all the list. Okay. And this I is growing from 0 to 1. Yeah, but in the next round, it's gonna be from 0 to 2, another one, so 0 to 3, and so on. Okay. Okay, so here we have to do a little bit of mathematics or calculation. So the point of this is that I have to sort or I have to find out the closest geometry in the all seeds, right? So basically the ways I can tell my distance to the all seeds is game object, the current game object is all seeds or I. Does this make sense to you? So if you have 10 geometries, it loops through each of them. Yeah. Okay. So the current I can detect the distance in between. So I'm going to say float dist is vector 3 It's a function of vector 3. You can calculate distance between two vectors. You see vector 1, vector A and B. So
Soomeen, don't we have to add more to the all seeds? Right now we only have one object.
Yeah, so that will be added in the update.
Okay.
Yeah, so you will see after I check the closest one, I will add a new seed. So after this update, it's gonna be nested.
Okay.
Okay, cool. So yeah, you are correct. There is only one currently. You are very correct. And this is the builder agent. Of course, you can use this location. Yeah. There's nothing different. Yeah. But you can also say builder agent transform location, position. Yeah, at this line. But I'm going to just use this line because it's the same vector. And current object location. Actually, what I actually need is not the object, I need the vector. Yeah, so I think I'm going to just get the current object position and get the vector 3 from here and just use transform position. So I don't have to do that here. Otherwise, I would have to have, say, current object dot transform position. Does this make sense? So I'm calculating the distance between the builder, the red dot builder agent, and the seed agent. Is that correct?
Yeah.
Okay. And now what I'm going to do is, the point is to get the closest geometry. So I'm going to set a number, a virtual number, and always test if this number is smaller. If my distance with this guy is smaller than the number, I will always replace. So I'm going to do this. So I'm going to have a float. I'm gonna set a float. Oh, sorry, not here. Set a float here. A closest distance. You can say closest distance is set to some kind of quite big number. And I'm going to compare my distance and that closest distance. So if distance is smaller than closest distance, I'm going to do something. I'm going to say, okay, the closest distance is now swapped to distance.
No, why? What does that do?
I'm just always checking what is the closest distance.
It just checks, okay.
Yeah. So I know, okay, now I know what is the closest distance. All right. And this is not enough because I also want, what I want is the closest seed object. So what I'm going to do is I'm going to set up also a virtual closest geometry. So game object, closest seed geometry, and I'm going to set a null, closest seed. Set it as a null, and whenever I detected a closer distance than the previous one, I will set it as all seed I. Does this make sense? It's just getting the closest. This is a way to get and return the closest geometry. Okay. All right. Now, after you have that, now after this line, I understand which one is closest to the new builder. I'm going to say, check which seed is the closest seed. So these lines does that. In the future, you can make this into a function, so you can use it in other scripts. So you can just use it around. Okay, after this line, we know what is closest one and new one. So now we have to calculate where we want to position that new seed right now. Yeah, so it's time for us to add a new seed. And what we are going to do is, so if we have the seed and if we have the builder, we are going to calculate the vector between these two and set a range. I'll set a number of how much distance I will always add the new one. And then eventually I will find this vector. So eventually I will find this position to position my next agent. Okay, and I will do this all many times. And every time when it only finds the closest one to add, eventually the resulting pattern will become a DLA. So that is the simplest algorithm. Okay, so now it's time for us to find the location, new location. Okay. Cool. So we have two agents and two locations. So vector 3, we are going to find the growing direction, right? So growth direction is myself, new builder location, minus, did you recap the vector plus vector mass, vector plus vector minus? So I don't have to explain that. So after this line, I know what is the closest seed. I will get its transform position. So this will become that orange vector. Do you remember? I just draw. So from here to here. So this is this vector, right? That's this vector. And I am going to scale this down. So I'm going to make this into a unit vector and scale a public number. So, okay, so let's see, normalize. So this means you can normalize this vector and you can actually, I think you can normalize with a value.
What is normalized?
Oh, normalize is you are making a vector into a unit vector. So the length is itself. Length is 1. Does it make sense? Yeah.
No, can you explain it a little bit further?
Okay, so you have a vector, and if you say normalize, it makes this vector into one unit long vector.
Okay.
Yeah, it scales to, it's unitizing a vector.
All right. That makes sense.
Okay. And then I'm going to scale this to certain amount that I can control outside. So I say public float. Let's say growth interval. Let's say the interval can be 1 for now. So this, if they're smaller number, they will be more dense. Yeah, if you can imagine. So I'm going to use this one. And I'm going to say, okay, growth direction is a normalized vector times growth, times growth interval. Growth direction. Growth direction. Cannot be. Okay, you can normalize it first. And just times this to itself. It's the same thing. Does this make sense so far?
So why didn't the other way work?
I don't know. I think this is a function and didn't want to have like function and operation in same line.
Oh, okay.
Yeah. All right. And then I have to make a new vector to define the next position. So vector 3, next seed position is my closest object position. So my closest seed transform position plus this growth direction. That's the new next seed position. Okay. And now we can copy this line. So Control C, Control V. So we are using the seed position to create a new prefab, instantiate the input prefab on the new position with no rotation, and all seeds put it inside this list. So in the next update, it includes this seed and doing it over and over and over again. Control S. We are ready to run this, and let's see if this does the thing. Yay. Yeah, it was really easy. Right? And you can change the interval, for example. So you can change the interval to, for example, 3. You can see that they're growing in a very loose position. And because the bird, the builder, is only created in that in the world range, that's why it doesn't grow over 20 by 20 by 20 by 20 box. So you can also change this world size as well. Okay, and I'm going to try to change this to 0 point into maybe 1.5 and 0, let's say 0.1. I want to make it really small because we are going to build it in AR. So DLA builder needs to be also very small. I think we need this to be like 2 centimeter or 5 centimeter, let's say. Okay. We can always zoom in. So this is seed geometry. Okay, 0.05. I think seed builder can be a bit smaller. Okay. So this is 1.5. Let's see what's the resulting geometry. Well, that's cool. Okay, so all right, so that is an interesting growing thing. Yeah, I'm gonna make this smaller, 0.05. Okay. And we are going to deploy this into our mobile app now.